Okay, actually, what I just did was the counter example principle. I drew 3 pictures and I had 2 counter examples that went against what their conclusion was. So that's one way that you can, show that a syllogism is invalid. Okay, what's next? Okay. Sometimes there are extra conditions that are present in the diagrams. For example, each diagram in figure 13.16, which is at the bottom here, illustrate the following premises. All A's are B's and some B's are C's. State a condition that is present in each diagram that has not been stated as a premise. This is pretty much what I just did. This one, let's see, let's go with green here. This one here, the extra premise is no A's are C's, because none of the blue circle is touching the yellow circle. And then this one, the extra premise would be some A's are C's, because of this little eyelet right here where the blue circle and the yellow circle are overlapping. And then this one would be all A's are C's, because the entire blue circle is enclosed in the entire yellow circle. So those are your extra premises, which I think they go over on this next slide. There they go. That's everything I just said. Because the circles containing A's and C's do not intersect, we have drawn the extra conclusion that, or extra condition that no A's are C's. And then in B, because the circles containing A's and C's do intersect, we have drawn the conclusion that some A's are C's. And then the last one, because we drew the circle containing A's inside the circle containing C's, we have the additional condition that all A's are C's. And there you go. And then the next slide starts me with my math lab examples, so I will do those separately.